The universe is full of strange and amazing space wonders scattered across its endless reaches. Some of these objects are so unusual and rare that even the mysteries of space seem ordinary by comparison. Among them are incredible planets that look a lot like Earth, while others exist in never-ending darkness, untouched by sunlight. There are worlds where non-stop sandstorms rage on, and others with giant oceans hiding glowing ice deep below. In the centers of bright nebulae, enormous stars exist, so strong they can destroy entire planetary systems. Even farther away, millions of light-years from us, are jellyfish galaxies moving through space, their glowing tentacles leaving trails of light in the darkness. Join us on a journey to discover some of the most unbelievable and mind-blowing wonders the universe holds. Scientists have always been fascinated by planets that might support the creation and continuation of life. However, finding such planets among the countless celestial bodies we've discovered so far is no simple task. To make this search more efficient, scientists developed a tool called the Earth Similarity Index, or ESI. This index helps them compare planets to Earth, which is considered the ideal standard for life as we know it. The ESI is calculated using a few key factors, including a planet's size, density, and average surface temperature. These elements allow scientists to estimate a planet's mass, its potential chemical makeup, the strength of its gravity, and whether it has an atmosphere. If an atmosphere exists, they can even analyze some of its features. Crucially, the ESI also helps determine if liquid water, a key ingredient for life, might exist on a planet's surface, along with other important details. Earth is the benchmark for this system, with its ESI set at a perfect 1. Other planets and celestial objects are compared to this standard and categorized into 3 groups. The first group includes objects with an ESI of less than 0.5. These are mostly gas giants, icy worlds, or planets that are either too hot or too cold to support life. Most planets and moons in our solar system fall into this category. Even a single extreme characteristic, like a temperature far outside the habitable range, can render a celestial body unsuitable for the development and survival of life. Let's take Venus as an example. This planet has a radius and mass that are very similar to Earth's, making it seem like a twin of our planet at first glance. However, because Venus is closer to the Sun and has an incredibly thick atmosphere, its surface temperature is unbearably high. This extreme heat makes it impossible for life to exist there. Despite its resemblance to Earth, Venus has a low Earth Similarity Index, ESI, of just 0.44. Celestial objects with an ESI between 0.5 and 0.7 fall into the second category. These worlds have more in common with Earth. Most of them are rocky planets with moderate temperatures, but they can also include ocean planets or even some large moons. However, having a high ESI alone doesn't guarantee that a planet can support life. Many low-mass planets struggle to hold on to a thick atmosphere, which is essential for protecting the surface. Without a strong magnetic field, these planets are left vulnerable to deadly radiation from their parent stars. Other planets may orbit too close to their star, causing them to become tidally locked, meaning one side always faces the star and becomes scorching hot, while the other side remains cold. These conditions significantly lower the chances of life forming or surviving. Now, in the third category, we find celestial bodies with an ESI above 0.7. These are the most Earth-like planets, but they are all located outside our solar system. According to current estimates, these distant exoplanets hold the highest potential for harboring life. though even here, nothing is guaranteed. Some planets in our universe are surprisingly similar to Earth in size and surface conditions. Among them, there's one that stands out as the most Earth-like. This remarkable planet lies just 12.5 light-years away from us and orbits a faint red dwarf star known as Teegarden star. Discovered in 2003, this tiny star is incredibly dim, about 1,270 times fainter than our Sun, making it impossible to see with the naked eye, despite its relative proximity. Teegarden star is a lightweight cosmic neighbor, with only 9% of the Sun's mass and a radius just 5% larger than that of Jupiter. Its gravitational pull barely sustains the thermonuclear reactions at its core, resulting in a surface temperature of about 2,630 degrees Celsius. Like other red dwarfs, it has a narrow habitable zone, located very close to the star itself. In 2019, astronomers studying the star's motion discovered 2 exoplanets in its system. One of these planets, named Teegarden C, orbits just outside the habitable zone. It follows a nearly perfect circular path at a distance of 0.045 astronomical units, completing one orbit every 11.5 days. Teegarden C is thought to be a rocky world with a mass 11% greater than Earth's and a radius 3.5% larger. However, its surface is far from welcoming. Due to the faintness of its star, the planet receives 63% less energy than Earth gets from the Sun. This keeps its average surface temperature at a frigid minus 47 degrees Celsius, too cold to support life as we know it. Still, scientists speculate that, like Jupiter's moons, Teegarden C might harbor salty oceans hidden beneath a thick layer of ice. The real star of the show, though, is the inner planet, Teegarden B. This planet is the most Earth-like world discovered so far, with a similarity index of 0.95, very close to Earth's perfect score of 1. It orbits much closer to its star, just 0.025 astronomical units away, and completes a full orbit in about 5 days. Its nearly circular orbit keeps it firmly within the star's habitable zone, where conditions could potentially support life. Teegarden B receives about 15% more energy from its star than Earth does from the Sun, possibly making it warm enough for liquid water. Teegarden's star B, a planet found orbiting a small red star, has caught scientists' attention because of its Earth-like traits. Its weight is only about 5% more than Earth's, and its size is nearly the same, meaning its gravity would feel much like what we experience here. This similarity suggests it might have a structure like Earth's. Scientists think it likely has a big metal core, surrounded by a thick, rocky layer and covered with a thin outer crust. One of the most interesting things about Teegarden's star B is its surface temperature. It's estimated to be around 28 degrees Celsius, 82 degrees Fahrenheit, about 14 degrees Celsius warmer than Earth's average. This warmth could allow liquid water to exist on its surface, an important ingredient for life. This temperature range is also thought to support many tiny life forms, making it even more likely that life could exist there. Still, there are some unknowns. The planet's air has not been studied closely yet because of the limits of the method used to find it. The type of air it has is very important. For instance, thick air with lots of methane and carbon dioxide could cause a strong greenhouse effect, making the planet much hotter. On the other hand, thick clouds of water vapor might block sunlight and keep it cooler. Either situation would have a big effect on how livable the planet is. However, the planet has its downsides. Teegarden's star B orbits very close to its star and is likely locked in place, meaning one side always faces the star while the other stays in constant darkness. This could lead to huge temperature differences between the two sides. Also, red dwarf stars often release sudden, strong bursts of energy that can increase their brightness by up to 30%. These flares could make life on the surface difficult. Even so, life has a way of surviving in tough conditions. For example, an ocean on Teegarden's star B could act as protection against harmful radiation and extreme temperatures. The upper layers of water might block harmful rays, while ocean currents could help even out the temperatures. In such an environment, simple life forms might develop in the warm, nutrient-rich waters. Over time, if conditions are right, these could evolve into more complex life. When we look at the many planets in the universe, we often focus on those that could support life. These planets usually have conditions that are just right: mild climates and welcoming environments. They grab our attention because they might be similar to Earth. On the other hand, some planets stand out because they are extremely dangerous, making them interesting in a completely different way. But then there is a third group: planets that act in strange, unexpected ways. One such world is a mysterious object discovered in 2009 near the Kepler 413 star system. At first, astronomers noticed an unknown object passing between Earth and a faraway star, briefly dimming the star's light. The scientists thought it was just an exoplanet passing in front of the star, as many other exoplanets have done before. They even figured out its size and mass, finding that it was a cool giant planet, 25 times heavier than Earth, and about 40% the size of Jupiter. But 180 days later, something strange happened. The object never crossed in front of the star again, even though astronomers were expecting it. The planet, which had been visible in earlier data, seemed to have disappeared. Theories were proposed. Perhaps a large dust cloud or a dark spot on the star's surface could explain the disappearance. But these ideas were soon ruled out. Then, after 800 days, the object reappeared, just as mysteriously as it had vanished. It crossed in front of the star 5 times before disappearing again. The truth about this strange object was eventually uncovered. It wasn't an ordinary planet. Kepler 413b, as it was named, has a very unusual orbit. It's located near 2 stars in a binary system, 36 times farther from its stars than Earth is from the Sun. Its orbit is constantly being pulled by the gravity of these 2 stars, causing it to wobble and shift. This results in an orbit that moves back and forth every 11 years, shifting by about 2.5 degrees from its usual path. At the same time, the planet's axis of rotation tilts dramatically by as much as 30 degrees. This constant shifting means that the planet's climate is very unpredictable. The area that gets the most sunlight from its stars moves around, from the equator to the poles and back again. As a result, temperatures on the planet change greatly, leading to extreme weather. It's likely that huge hurricanes, even larger than Jupiter's Great Red Spot, form on the planet. These storms send clouds of ice moving at speeds of several kilometers per second. Eventually, the storms become unstable and break apart, but the energy released by the planet's swirling winds can be so strong that it sends gas and matter flying into space. Some of these emissions stay in space for a while before gravity pulls them back to the planet. With its unpredictable orbit, constant changes in climate, and enormous storms, Kepler 413b would be a very harsh and unstable place to live. Although this distant world may seem like a calm and peaceful island compared to what follows, it's far from peaceful. Located 190 light-years away from Earth in the HD 10606 system, this star is a yellow dwarf, similar to our Sun in many ways. Orbiting this star is a strange planet with a wildly changing climate. The planet rushes toward its parent star like a giant comet, burning fiercely in the hot heat of the star's outer atmosphere. Then, just as quickly, it moves back to the outer parts of its orbit. This gas giant is 4 times the mass of Jupiter, with a radius slightly different from Jupiter's. At its farthest point from the star, it is 88 astronomical units away, receiving roughly the same amount of heat that Earth gets from the Sun. Scientists believe that when the planet is at this far point, the conditions on its moons could be similar to those on Earth. Clouds made up of water droplets, ice crystals, or even tiny pieces of quartz might form in the planet's atmosphere, creating an environment that could support life on its moons. However, as the planet swings closer to the star, the situation changes quickly. In just 55 days, it shortens the distance between itself and the star by nearly 30 times. This increase in closeness causes the energy the planet receives to jump by 800 times. Observations show that at its closest point, the temperature on the planet can rise from 500 degrees Celsius to 1200 degrees Celsius in only 6 hours, nearly doubling in just that short time. These extreme shifts in temperature cause violent storms, with hurricane-force winds reaching speeds of up to 5 kilometers per second. The planet's atmosphere absorbs huge amounts of heat, causing it to expand quickly, producing shock waves that travel across the entire planet. The temperature rise also breaks down water vapor into oxygen and hydrogen, while quartz crystals evaporate completely, only to later come together again into huge sand clouds. The extreme conditions make this gas giant a place of constant, violent change. HD 10606b is likely the only planet in its system. The gravity of a nearby star has changed its orbit and disrupted the protoplanetary disk, making the presence of other large objects unlikely. Though planet instability from the influence of nearby stars is not unusual, in this case, the situation is special. Over 1,500 light-years away in the Kepler-36 system, a similar kind of planetary chaos happens. The system's main star is a yellow subgiant, about 62% larger in radius than our Sun, but with a similar mass. 2 planets orbit this star closely, a rocky super-Earth and a burning mini-Neptune. Every 97 days, these 2 planets come dangerously close to each other, within just 1.9 million kilometers, about 20 times closer than the distance between Earth and Venus. When they approach, their gravitational pull causes huge problems on both planets. However, after a few days, the planets move apart, until they repeat this dangerous cycle once more. The gravitational forces between the planets in a particular system are so strong that, at their closest point, the pull is 13 times stronger than the Earth-Moon connection. This powerful force could cause serious harm to the rocky planet, especially to its surface. Under these huge pressures, the planet's outer layer could crack and move, causing earthquakes of unimaginable power. Large cracks could open up, stretching for hundreds of kilometers, while huge volcanic eruptions could happen. Some areas of the planet might stay extremely hot, with seas of molten lava that never cool down, constantly bubbling at scorching temperatures. The origins of such an unusual planetary system are still being discussed. We know that the planet, called Kepler-36b, orbits its star at a distance of 12 astronomical units and completes a full orbit in just 14 days. This super-Earth, with a mass nearly 4 times that of our planet, is much bigger, having a radius 1.5 times greater than Earth's. Its temperature is about 980 Kelvin or 700 degrees Celsius, and its average density is about 30% higher than Earth's. Some scientists think it could be the exposed core of a gas giant that lost its thick atmosphere, leaving behind a dense mix of heavy metals like iron and lead, along with sulfur and silicon compounds. The lighter elements that once made up its outer layers could have been blown into space by the star's strong winds, helped by the gravitational pull of its nearby companion planet. That companion, Kepler-36c, is a hot mini-Neptune. It orbits in a nearly round path around its star at a distance of 1.3 astronomical units, completing an orbit every 16 days. With a mass 7 times that of Earth and a radius 3.7 times bigger, it's a planet of huge size and heat, with a surface temperature of 928 Kelvin, about 650 degrees Celsius. Its atmosphere, made mostly of nitrogen, hydrogen, and helium, becomes dense and thick as you go deeper into the planet, eventually forming a supercritical fluid around the solid core. The gravitational pull between these two planets creates a messy and unpredictable system. The huge gravity of the bigger planet could capture moons or satellites from the smaller one, only for tidal forces to tear them apart, forming streams of asteroids. Additionally, the mutual gravitational pull of the planets bends their orbits, changing their shapes and other orbit details, making the entire system behave unpredictably. Modeling suggests that there's a 91% chance these two planets will crash into each other within the next 70 million years. Causing a huge explosion that will send debris flying through the system, causing even more chaos. Meanwhile, in another part of the galaxy, about 434 light-years from Earth, there exists a remarkable object often called Super Saturn. This brown dwarf is located 4 astronomical units from a young Sun-like star, and it's a huge gas giant 20 times heavier than Jupiter. At just 15 to 16 million years old, this planet is still forming, with a hydrogen and helium atmosphere around a metallic core. It is also surrounded by a huge system of rings, much bigger than Saturn's, with at least 37 separate rings. The outermost of these rings stretches to about 6 astronomical units in radius, almost the size of Venus's orbit. This ring system, with a mass greater than Earth's, behaves in unpredictable ways. Some particles in the rings lose speed and fall into the central planet, while others speed up and escape into space. This process can take hundreds of millions of years, and during this time, the system is likely to go through major changes. Interestingly, a large gap in the rings, about 4 astronomical units wide, suggests the presence of an exosatellite, an object that has cleared its orbit of smaller debris, possibly forming the gap in the rings. Other objects, around 30% of Earth's mass, have also been spotted orbiting the brown dwarf. Simulations of this system, which include radiation from the parent star, heat from the gas giant, and tidal forces, suggest that the exosatellites could have surprisingly comfortable temperatures. The night sky on such a satellite would be stunning, with the brown dwarf filling 70 times the sky area of the full moon. Its soft glow would bathe the surface in a twilight haze, and the sky would be filled with vast swaths of light. The tidal forces from the nearby giant planet could cause frequent volcanic eruptions on the surface, while the possible ocean would unleash giant waves that could stretch for hundreds of kilometers, creating a unique climate zone between land and sea. However, such systems are often unstable, and their appearances can change drastically over time. It's uncertain how long these giant rings will stay intact or how the system will evolve in the coming millions of years. For centuries, people have wondered about the existence of huge space objects, as big as planets, that float freely without being attached to any star. These strange space travelers are often called orphan planets, free-floating planets, or rogue planets. Unlike planets that circle stars, rogue planets move through the vast emptiness of space by themselves and give off very little heat or light. This lack of energy makes them extremely difficult to find. Rogue planets are special because they don't have nearby objects, like stars, to affect or hold on to them. Their loneliness makes it even harder to study. It wasn't until the early 21st century that scientists spotted the first possible rogue planets. The warmest of these can be seen using infrared telescopes, while others are found through a method called gravitational microlensing. This method involves watching how a rogue planet's gravity bends light from a faraway star when it moves in front of it. Even now, rogue planets remain one of the most puzzling and least understood types of space objects. Only 3 rogue planets have been fully confirmed, though astronomers have found over 24 possible ones. Surprisingly, data from the OGLE project suggests that our galaxy, the Milky Way, might have as many as 100 billion rogue planets. This shows that we've barely begun to learn about these wandering worlds, and many more discoveries are likely waiting. For years, what we knew about rogue planets came mostly from theories and educated guesses. But now, advances in powerful observation tools have finally allowed scientists to test these ideas. The closest confirmed rogue planet to Earth, discovered in 2014 using NASA's WISE infrared telescope, is called WISE J08550714. This planet is about 7.27 light-years away from the Sun and can't be seen with normal telescopes because it doesn't give off any visible light. Its temperature is extremely low, ranging from -48 degrees Celsius to -13 degrees Celsius, which explains why it doesn't glow. Scientists believe WISE J08550714 is a cooled-down gas giant, much like Jupiter, and it's over 1 billion years old. It's mostly made of hydrogen, and its cold, dark nature makes it a fascinating subject for astronomers. In 2016, the Gemini Observatory uncovered fascinating evidence pointing to large amounts of water in the atmosphere of a mysterious celestial object. Scientists believe this water may have condensed into clouds made of extremely tiny ice particles. Despite these findings, the origin of this object remains a mystery, and researchers have proposed 2 main theories to explain its existence. The first theory suggests that such objects begin their lives in the protoplanetary disk of a standard planetary system. This is the region of gas and dust where planets form around a star. Mathematical simulations indicate that if the original gas and dust cloud is massive enough, at least one planet could be ejected from the system. This could happen due to gravitational forces, such as a close encounter with a massive star or the collision of 2 planetary systems. Although such events are rare, they offer a plausible explanation for how the object could have been cast out into interstellar space. The second theory proposes that this object formed in the same way as stars do, through the compression of interstellar gas. However, its mass was too small to ignite thermonuclear reactions, the process that powers stars. Instead, it became a failed star, known as a gas giant or a brown dwarf. Unlike Earth-like rocky planets, these bodies are composed mostly of gas and lack a solid surface. Scientists are divided on how to classify such objects. Some argue they should not be considered rogue planets, but rather sub-brown dwarfs. Others suggest a new term, plano, to describe all interstellar wanderers that show no thermonuclear activity. Based on current knowledge of brown dwarfs and gas giants, the mass of this object, identified as WISE 0855 0714, is estimated to be between 3 and 10 times that of Jupiter. While this mass is not enough to trigger thermonuclear reactions, it is sufficient to trap heat within the object, keeping it relatively warm. Research by David John Stevenson from the University of California provides insight into what conditions on such an object might be like. He explains that gas giants, like Jupiter, do not cool down quickly after drifting away from their star. Their thick hydrogen atmospheres act as effective insulators, trapping heat generated by their dense metallic hydrogen cores. This trapped heat could create conditions suitable for liquid water to exist in the lower atmosphere. Scientists believe water may be present in the form of giant clouds made of tiny droplets, supported by mathematical models from the University of Edinburgh. These models suggest that the surface temperature of WISE 0855 0714 is about 250 Kelvin, or roughly minus 23 degrees Celsius. The atmosphere also features a relatively warm layer, about 100 kilometers thick, with densities comparable to those found on Earth. Such an environment might even support the basic conditions necessary for organic life. Interestingly, a planet doesn't need to be a huge ball of gas to survive the cold, vast areas of space. In 2020, scientists discovered a possible rogue planet using a method called gravitational microlensing. The object, which still hasn't been completely confirmed as a rogue planet, was given a long and complicated name, and its features are still being studied, but early information gives us some clues. This planet seems to have a mass similar to Earth's and is located somewhere between 30,000 to 180,000 light-years away. Based on what we currently know about science, an object with that mass is unlikely to be a gas giant. Instead, it's probably a rocky planet. This makes us think that the object might have formed in the disk of a planetary system during the system's early stages. It might have been kicked out of that system by a violent event, like a cosmic explosion, or perhaps the gravitational pull of a bigger neighbor. Once it was thrown out, it would have been left to wander the universe alone, becoming what we call a free-floating planet. The planet has a thick enough atmosphere it could stay thermally protected, which means it could trap heat. If there's a layer of ice on its surface, it could also help keep the heat in. On top of that, if the inside of the planet remains extremely hot, with radioactive elements breaking down, any water or ocean the planet might have could stay in liquid form. If the planet still had a moon, it could have kept it after being thrown out. This moon could continue to create tidal forces that would heat the planet's outer layer. In theory, if conditions are right, simple life forms might have survived, though finding any trace of them would be nearly impossible now. Most of what we know about rogue planets today has come from advanced mathematical models and complex calculations. These calculations were possible thanks to small bits of data collected by both Earth-based and space telescopes. One current project, called Cleopatra, aims to find more free-floating planets and understand their features better. The main method here is microlensing, which happens when a celestial object passes in front of a distant star, briefly blocking the star's light. From Earth, scientists can watch this moment from different angles, allowing them to calculate the object's distance, mass, and size. As part of the Cleopatra project, a spacecraft is being developed. It's planned to launch in 2025, alongside a mission to Mars. After leaving Earth, it will enter orbit around the Sun, and it will be supported by artificial intelligence that will help analyze all the data collected. This mission promises to bring us many exciting discoveries about these mysterious worlds. In theory, a rogue planet might get captured by the gravity of a star and become part of a planetary system. But the chances of that happening are very low. Most of these wandering worlds are doomed to drift through space for billions of years, slowly cooling down, until they are eventually pulled into black holes or destroyed by cosmic disasters, taking their secrets with them into nothingness. In 2003, while scientists were regularly studying the night sky, they made an interesting discovery: a small yellow star in the Phoenix constellation. This star was later named WASP 96. 10 years later, in 2013, the Super WASP Orbital Telescope picked up an amazing finding. A rare gas giant planet was located near this star. Early tests on the planet's atmosphere showed something strange. It was incredibly clear, almost completely lacking in water vapor. Fast forward to 2022, and scientists used the new James Webb Space Telescope to study the planet again. This new telescope, known for its incredible precision, provided even more detailed data. But what they found left everyone shocked. According to the James Webb Telescope's readings, the planet appeared to be surrounded by thick clouds, something completely different from what the earlier observations had suggested. This new information conflicted with the earlier findings, leading scientists to question everything they thought they knew about this distant world, and more broadly, about our understanding of the universe. So, what exactly is this powerful telescope, and what amazing secrets has it uncovered in the far reaches of space? Let's take a deeper look. The story of the James Webb Space Telescope, the largest and most advanced orbital telescope in modern history, began in 1996. It took over 25 years of development and upgrades before it was ready for launch. Once it left Earth, it traveled for about a month, covering 1.5 million kilometers to reach its designated position in space. Equipped with the latest infrared sensors, the James Webb Telescope is capable of spotting the faintest, most distant objects hidden in the far corners of the universe. However, this amazing sensitivity has a downside. The bright radiation from Earth, the Moon, and the Sun can interfere with the telescope's ability to pick up weak signals from far-off stars and exoplanets. To fix this, the telescope is shielded by a special multi-layer heat-resistant screen that blocks out these disturbances. The telescope also had to be placed far from the influence of large celestial bodies, positioned at a special location called the second Lagrange point, where it stays in the shadow of Earth. Despite these challenges, the results have been nothing short of stunning. Since it began its mission, the James Webb Space Telescope has uncovered countless wonders of the universe, some of which were expected, while others have raised even more fascinating questions, pushing the limits of our knowledge further than ever before. One of the most surprising discoveries came from studying the exoplanet WASP 96b, which is a bright world with an incredibly low density. This exoplanet orbits its star, known as Saint, at a very close distance, just 0.045 astronomical units away. It takes only about 3.5 days to complete one full orbit. Despite its small size, its mass is about half that of Jupiter, and it has a diameter that's 20% larger than Jupiter's. Due to its extreme closeness to its parent star, the planet's outer layers reach very high temperatures around 1,285 K, just over 1,000 degrees Celsius. WASP 96b belongs to a group of exoplanets known as hot Jupiters, which are large and often lose their atmosphere because of the strong radiation from their stars. Early observations of WASP 96b showed strong sodium lines in its atmosphere, suggesting it had a very clear and cloudless atmosphere. This was puzzling, as current models of gas giants suggest that sodium should only exist deep within a planet's interior. The presence of sodium so high up in the atmosphere indicated that the upper layers of the planet were not absorbing light, leading researchers to think that the planet's atmosphere might be unusually clear. Scientists believe this might allow the James Webb Space Telescope, JWST, to see deeper into the planet's interior, but the results were surprising. Instead of finding a clear view, JWST discovered that the outer layers of the planet's atmosphere contain large amounts of water vapor. This water vapor condenses in the upper atmosphere, creating a thick haze or clouds that reflect much of the light. This cloud cover could mean that the temperature in the lower layers of the planet is much different from what was previously calculated. It's possible that earlier models weren't accurate enough, or that some data was misunderstood. Another possibility is that there is a factor we haven't yet identified, which could explain these unexpected results and help us understand the planet more clearly. WASP 96b remains a mystery, requiring more study to reveal its secrets. In addition to WASP 96b, JWST has made other amazing discoveries. For example, 69 light-years away, there is a strange system consisting of 3 brown dwarfs. These objects are too large to be considered planets, but too small to start nuclear fusion like stars. Brown dwarfs are often hard to detect because their surface radiation is so weak. But because JWST mainly observes in the infrared spectrum, it can easily spot these objects, which are nearly invisible to regular optical telescopes. The 2 largest objects in this system are very similar to each other in terms of their characteristics, and they are positioned relatively close together, with a distance of about 2 astronomical units separating them. Together, their total mass is just a bit more than 100 times that of Jupiter. Both objects have relatively high temperatures, reaching up to 2,600 Kelvin, or just over 2,300 degrees Celsius. The third object in the system is much farther away, sitting about 100 astronomical units from the center. Its mass falls between 14 and 23 times the mass of Jupiter, and its radius is 20% larger than that of Jupiter. This brown dwarf is also significantly colder than its more massive companions, with the temperature of its outer layers only about 1,240 Kelvin, or just under 1,000 degrees Celsius. However, it is still much warmer than the gas giants in our solar system, even though it doesn't have a star to heat it. What's surprising is that the outer layers of this brown dwarf contain not only typical components like water, methane, and carbon dioxide, but also tiny particles of various silicon compounds. The simplest of these compounds is quartz, but scientists have also found more complex substances. These compounds are thought to form large clouds in the brown dwarf's atmosphere. Scientists had predicted the presence of these silicon-based clouds based on theoretical ideas, since silicon is common in the universe as a byproduct of stellar reactions. However, it wasn't until recently that observations confirmed this hypothesis. Around 140 million years ago, the system might have been a single cloud of gas and dust, which later split into 3 separate clumps. This splitting might have been caused by the gravitational pull of a massive object that passed too close to the cloud. Interestingly, if the splitting hadn't happened, the total mass of the resulting object would have been enough to start a self-sustaining nuclear reaction. In that case, instead of 3 brown dwarfs, we might have ended up with a small star. The James Webb Space Telescope, with its powerful equipment, is not only capable of observing distant objects in space, but can also capture enormous structures stretching across hundreds of light years. One such structure is the Carina Nebula, one of the largest stellar nurseries in our galaxy. Located about 8,500 light-years from Earth, the Carina Nebula has a mass up to 900,000 times that of our Sun. It contains massive clouds of gas and dust, as well as thousands of stars, ranging from the smallest to the largest. This nebula is home to 2 of the Milky Way's brightest stars, Ia Carinae and W25, which shine millions of times brighter than the Sun. Objects like these always grab the attention of astronomers. James Webb's infrared cameras can also peer through the dusty haze of the nebula, revealing many stars that were previously unknown to us. This area of space is teeming with hundreds of young stars, which are constantly being born. Modern theories suggest that new stars form when gravitational forces compress and heat clouds of cosmic dust. As these clouds evolve, a protostar forms and goes through several stages before it finally starts nuclear reactions in its core. While this theory is supported by many observations, there are still many details of this long and complex process that scientists are working to understand. The formation of a new star can take millions of years, but thanks to the infrared capabilities of the James Webb Telescope, astronomers can observe thousands of protostars and young stars at various stages of development in the Carina Nebula. It's fascinating to note that all of these stars form from the same gas cloud, so they share similar compositions and ages. By studying them, scientists can track the entire process of star formation and gain a better understanding of the forces involved. Some stages of this process, which were once only predicted in theory, can take hours or even days to unfold. However, with the James Webb Space Telescope, the chances of capturing these events have greatly improved. Soon, we might even get to see a photo of a young star suddenly lighting up thousands of light years away from our Sun. Meanwhile, the telescope's 18-section mirror, which spans 6.5 meters in diameter, and its highly precise instruments allow it to capture light from objects that are incredibly far away, right at the edge of the visible universe. These objects are over 13 billion years old, offering us a rare glimpse into the very beginning of time, right after the hypothetical Big Bang. Even with all its power, however, James Webb would not have been able to capture the glow of these distant objects if it weren't for a unique and rare phenomenon: gravitational lensing. This effect, which scientists have known about for a long time, makes it possible to see far deeper into the universe. Here's how it works. When a huge mass, like a galaxy or black hole, exerts a powerful gravitational pull, it bends and magnifies the light from objects behind it. This effect can only happen under very specific conditions, so it is incredibly rare. What makes this discovery even more extraordinary is that while observing the galaxy cluster SMACS 0723, located about 4 billion light-years away from Earth, the James Webb Telescope captured light from a distant object that passed through this gravitational lensing effect not once, but 3 times. This magnified the light by about 20 times, which was crucial because without it, the object's light would have been too faint to detect amid the background noise. Scientists believe that the object in question is an ancient galaxy, approximately 13 billion years old. In addition, the telescope has detected around 10 other star clusters, which are thought to have formed between 200 and 700 million years after the birth of the universe. Some of these clusters appear to have complex structures, which may have taken tens of millions of years to develop. Exoplanets differ greatly in their features and surroundings. Some are extremely large, even bigger than Jupiter, while others are much smaller and more similar in size to Earth. The conditions on these planets can be extreme. Some are very hot with huge oceans of molten lava, while others are completely frozen, covered in layers of permanent ice. Some planets are completely made of oceans with no land at all, while others have strange weather, like rains of sulfuric acid or even snow made of diamonds. To find these faraway worlds, scientists use different methods, as spotting an exoplanet with just a regular telescope is nearly impossible. That's why in 2009, NASA launched the Kepler Space Telescope, specially designed to search for planets outside our solar system. Kepler was equipped with 42 charge-coupled devices, CCDs, which gave it a total resolution of about 96 megapixels. With its wide view, covering about a quarter of the sky, and a mirror with a diameter of 1.4 meters, Kepler could spot planets up to 3,000 light-years away. In the 3.5 years that it worked, Kepler found more than 12,000 possible exoplanets. Of these, over 2,000 have been confirmed through repeated checks. During this time, Kepler also discovered the smallest known exoplanet, Kepler 37b, which is only about a third of the size of Earth. The telescope also helped spot many stars and brown dwarfs, which are objects that are too small to be considered stars, but too large to be planets. Kepler used a method called the transit method to find these exoplanets. This method involves looking for small drops in the brightness of a star. If a planet moves in front of its star, as seen from Earth, it causes the star's light to fade slightly. The amount of fading depends on the sizes of the planet and the star. The regularity of these fading events allows scientists to calculate how long it takes for the planet to orbit its star. The transit method of detecting exoplanets requires accurate measurements. Even small changes in a star's light, often less than 2%, are enough to show the presence of a planet. These changes are usually tiny ripples, often no bigger than 1/10 or even 1/100th of a percent. However, this method is sensitive to interference, especially from Earth's atmosphere, where dust and rain can harm the results. That's why space telescopes are important for finding objects far beyond our solar system, where the atmosphere doesn't get in the way. In 2013, just 3.5 years into its mission, the Kepler Space Telescope faced several major malfunctions. By 2018, the telescope had completely stopped its scientific work. Kepler was the first spacecraft built specifically to search for exoplanets. Despite its groundbreaking work, it mainly discovered distant, faint objects that were too far and dim to study in much detail. This led to the creation of the next generation of space telescopes, designed with different goals in mind. The Kepler mission was followed by the Transiting Exoplanet Survey Satellite, TSS, which NASA launched on April 18, 2018. TESS's main goal was to search for rocky exoplanets orbiting some of the brightest stars within 200 light-years of Earth. Like Kepler, TESS uses the transit method to detect exoplanets. Let's take a quick look at TESS's specifications. It has 4 cameras with a field of view of 24 degrees by 24 degrees, and each camera has a 16.8 megapixel CCD. The spacecraft's special orbit allows it to observe almost the entire sky, around 85% of it, covering both the northern and southern halves. One of TESS's most exciting discoveries was the exoplanet TOI 700d. This planet is the first Earth-sized object found in the habitable zone around its star, where conditions might be right for liquid water. The star it orbits, TOI 700, is a red dwarf located just over 100 light-years away from the Sun. It's a small, cool star with a temperature about half that of the Sun, and its mass and size are just 40% of the Sun's. Interestingly, TOI 700 is a very stable star, having not shown any solar flares since observations began. This stability is important for supporting life, as solar flares can strip planets of their atmospheres, making them less likely to support life. TOI 700 has at least 3 planets orbiting it, one of which is TOI 700b. This planet is roughly the same size as Earth, with a mass about 1.07 times that of Earth and a size that differs by no more than 2%. Unfortunately, TOI 700b is too close to its star, just 0.06 astronomical units away. A year on this planet lasts only 10 days, meaning it's much too hot to support life. The planet TOI 700c is probably tidally locked to its star, meaning it always shows the same side to the star. As a result, one side of the planet could be very hot. TOI 700c is farther from its star than the other 2 planets in the system and is called a mini-Neptune. Its mass is thought to be between 5 and 13 times that of Earth, and its radius is 2 to 3 times bigger. The planet takes 16 days to orbit its star. Since it is located closer to the star than the habitable zone's inner edge, conditions on the planet are too extreme for life to form or survive. TOI 700d, the third and farthest planet in the system, is in a better position. It orbits its star in 37.4 days and is near the inner edge of the habitable zone. While the exact mass of TOI 700d hasn't been figured out, it's believed to be between 1 to 3 times Earth's mass. The planet's radius is about 20 to 30% larger than Earth's. Scientists think TOI 700d is rocky, but they don't yet know its exact makeup. It gets 86% of the energy from its star that Earth gets from the Sun. If its atmosphere is like Earth's, the surface temperature is estimated to be about minus 4.3 degrees Celsius, 268.2 K. However, this could change depending on the planet's greenhouse effect or atmospheric conditions, which are not fully understood. The eccentricity, or the oval shape, of TOI 700d's orbit is thought to be small, around 1, meaning it stays relatively close to a circular path. However, there may still be times when the planet gets too close to its star, moving out of the habitable zone. Despite this, its year is shorter than ours, lasting only about a month. If life exists on TOI 700d, it could survive these extreme periods by going into a dormant state or moving to cooler areas. Though the data from the spectral analysis of TOI 700d isn't enough to confirm everything, there is a chance that liquid water exists on its surface. The greenhouse effect could also warm the planet to temperatures that might support life. Like the other planets in the system, TOI 700d is probably tidally locked to its star, meaning one side is always facing the star. This creates a big temperature difference between the sunny side and the shadowed side. If the atmosphere is thick enough, it could help balance out these extreme temperatures, but this could also lead to powerful hurricanes. Meanwhile, the TESS mission, which is designed to look for exoplanets, has completed its main goals but keeps collecting data. It will continue taking pictures of the sky, including the challenging region of the Milky Way plain. So far, TESS has discovered over 2,100 exoplanet candidates, with 66 of them already confirmed. Additionally, the mission has recorded 6 supernova flares, found 3 exocomets, and taken many photos of smaller objects in our solar system, which, while not part of the main mission, are still useful for scientific research. Just before Halloween in 2020, NASA released a list of some of the scariest worlds in the universe. Among these strange places were 6 exoplanets, each with environments so extreme that no living creature could survive there. Even getting close to these planets could be deadly. One of the most frightening objects on this list is a black gas giant called TRES 2b. This planet orbits a star named TRES 2, which is a yellow dwarf located 7 to 18 light-years away from Earth. This gas giant has some special features that make it one of the darkest planets ever discovered. Its surface is made of materials that absorb over 99% of the light that hits it, giving it a completely black appearance. Scientists are still confused about why the surface absorbs light in this way. Unusual chemical reactions may be happening on the planet's surface, reactions we've never seen before. This strange phenomenon makes TRES 2b the darkest exoplanet known to us. TRES 2b was first discovered on August 21, 2006, and more details about its features were found in the years following. The planet's mass is 1.2 times that of Jupiter, and its radius is 1.27 times bigger. The atmosphere is extremely hot, with temperatures reaching up to 1,000 degrees Celsius. This heat causes the planet to glow with a faint red color, similar to the soft glow of burning coals. Even though TRES 2b has a frightening appearance, it's not the most dangerous place in the universe. Other objects in space are even more terrifying, hiding out there in the vastness of the cosmos. Another fascinating exoplanet, designated 55 Cancri e, is located in the system of a star that is similar to our Sun, named 55 Cancri a. This celestial object was first discovered on August 30, 2004, using the Doppler spectroscopy method. The planet's mass is about 8 times that of Earth, and its radius is nearly 1.875 times larger than Earth's. 55 Cancri e is tidally locked, meaning one side of the planet always faces its parent star, while the other side remains in permanent darkness. As a result, the side that is exposed to the star is extremely hot, reaching temperatures up to 2,400 degrees Celsius, while the dark side is slightly cooler at 1,300 degrees Celsius. These extreme temperatures are caused by the planet's proximity to its star, located only 0.183 astronomical units away, much closer than Earth is to the Sun. The planet is likely to have volcanic activity, which creates dust clouds that trap heat, preventing it from escaping into space. These dust clouds act as a blanket, keeping the surface of the planet incredibly warm. The planet's orbital period is just under 18 hours, which means it completes one full orbit around its star in less than a day on Earth. As for its atmosphere, 55 Cancri E contains helium, hydrogen, and large amounts of carbon. This carbon could potentially form thick layers of graphite and diamonds deep within the planet's interior, making it a truly unique and exotic world. 55. Cancri E is not the only planet in its system. 4 other planets are orbiting its host star, and their environments are much more hospitable compared to 55 Cancri E. This is what sets the 55 Cancri A system apart from another intriguing exoplanet system known as Poltergeist, or PSR 1257+112c. This planet orbits a pulsar, a highly magnetized rotating neutron star. Located just 0.36 astronomical units from its pulsar, the Poltergeist wouldn't have survived the supernova explosion that preceded the formation of the pulsar. It is believed that Poltergeist formed from the debris left behind by this explosion. Another theory suggests that the pulsar itself was born from the collision of 2 white dwarf stars, which doesn't necessarily involve a massive explosion. However, since Poltergeist is the first of its kind to be discovered, scientists are still uncertain about its exact origin. The star system we're talking about is located 2,300 light-years away from Earth. The object at the center of this system is about 4 times the mass of our planet, and it takes about 66 days to complete one full orbit. One of the most impressive features of this system is the huge radiation released by the pulsar at its center. This radiation is so strong that any spacecraft trying to get too close would be destroyed by the force. Even with all these extreme traits, this exoplanet isn't actually the most dangerous one we've found. If a space object gets too close to this system, it could be torn apart, but this is nothing compared to what would happen near a different star in the same area. Planet Kepler 70b, which is the hottest exoplanet we know of, takes danger to a whole new level. It orbits around a star called Kepler 70, a subdwarf star that's much hotter than our Sun, with a surface temperature reaching 6,800 degrees Celsius. Kepler 70b itself has only about 44% of Earth's mass and a radius of just 76% of Earth's size. Its orbit is incredibly fast, completing one revolution every 345 minutes, meaning a single day on Kepler 70b lasts less than 6 hours. An interesting feature of this exoplanet is that it regularly passes very close to another object in the system, Kepler 70c, at a distance of only 240,000 kilometers. This is the closest encounter between 2 planets that we've ever recorded. The extreme heat on Kepler 70b may be due to the idea that it could have once been a part of its parent star, but scientists need more proof to confirm that this is indeed an exoplanet. So, for now, it remains an open question. Interestingly, Kepler 70b isn't the only space body interacting so closely with its parent star. Another example is the exoplanet known as WASP-12b, located 870 light-years away. This giant planet has a radius nearly twice that of Jupiter and a mass 1.46 times that of Jupiter. It orbits very close to its host star, just 0.03 astronomical units away, which is why it experiences temperatures up to 2,200 degrees Celsius. Because of its proximity, the host star's strong gravity is slowly pulling WASP-12b in, and scientists predict that in about 10 million years, the planet will be destroyed. Given all these extreme conditions, it seems unlikely that scientists will prioritize exploring these kinds of exoplanets. They may seem unremarkable at first glance, but in reality, these worlds could have features that are more dangerous and extraordinary than we realize. When flying past the planet HD 189733b, it might seem like an ordinary, safe world at first glance, because it looks a lot like Earth. But if you were to get closer and enter its atmosphere, you'd quickly realize how dangerous it is. The planet's winds blow at frightening speeds, reaching up to 8,700 kilometers per hour, and they carry tiny pieces of silicate, essentially dust that could hurt anyone caught in it. As if that wasn't bad enough, the rains on this planet don't fall like normal water. Instead, they're made of molten glass, sharp burning droplets that would be deadly to anyone exposed to them. These extreme weather conditions happen because of the planet's intense heat and the strange makeup of its atmosphere. Speaking of its orbit, HD 189733b moves around its star in just 2.5 days, and it's likely tidally locked, meaning one side of the planet always faces the star while the other side is in constant darkness. To give an overview of the planet, HD 189733b is a large, bright blue gas giant orbiting an orange dwarf star in the constellation Vulpecula. It's located just 63 light-years away from Earth, not too far in the grand scheme of things. The planet is about 1.1 times the size of Jupiter and weighs 113% of its mass. Interestingly, HD 189733b orbits its star from only 5 million kilometers away, which is 30 times closer than Earth's distance from the Sun. This closeness causes the planet's surface temperature on the day side to reach a burning 930 degrees Celsius, while the night side stays hot at around 425 degrees Celsius. When HD 189733b was first discovered, scientists immediately began studying it, and in 2007, data from the Hubble Space Telescope revealed fascinating details about the planet's atmosphere. It turns out that the atmosphere is thick with a fog, and when the planet passes between the observer on Earth and its star, the fog causes the atmosphere to turn a reddish color. This strange hue may be due to particles like iron silicates and aluminum oxide floating in the air. Further studies also uncovered the presence of water vapor, neutral oxygen, and organic methane compounds in the atmosphere. Perhaps the most puzzling discovery was the unusual variety of methane found on the planet. This methane behaves differently than expected, glowing in a fluorescent state and giving off electromagnetic radiation in the infrared range. This suggests that there may be some mysterious activity happening in the planet's atmosphere, something scientists have yet to fully understand. HD 189733b is a prime example of how exploring planets with extreme environments can lead to surprising discoveries about the processes occurring there. The idea that there could be planets completely covered in water, also known as ocean worlds, started to take shape in the 1970s. Scientists discovered that a planet's internal radioactive decay and the tidal forces acting on it could melt water ice and create vast oceans beneath the surface. Similar processes are likely happening on some of Jupiter's and Saturn's moons. However, these moons remain frozen because they are too far from the Sun to receive enough heat to melt the thick ice that covers them. When we talk about an ocean planet, we're referring to a different kind of space object. In this case, the planet's oceans aren't hidden under ice. Instead, they are exposed on the surface. Additionally, these oceans are incredibly deep, often more than 100 kilometers deep. In 2004, French astrophysicists led by Christophe Sautin created theoretical models to study how such planets could form and evolve. Their theory suggests that if a planet's mass is more than 10 times the mass of Earth, it will start to attract hydrogen and helium from the gas and dust around it, eventually growing into a gas giant. On the other hand, if a planet has a mass between 6 and 8 times that of Earth, it will mostly consist of ice and rocks, with roughly equal amounts of each. To give you some perspective, all the water in Earth's oceans makes up only about 0.025% of the Earth's total mass. If a planet's orbit is far from its star, it will likely be either an ice giant or a cold super-Earth. In these cases, radioactive decay within the planet's core might melt some of the ice, creating a subsurface ocean. However, the outer layers of the planet will remain frozen. If a planet ends up in the habitable zone of its star, where conditions allow liquid water, its outer layers could melt and form a huge, endless ocean. Models suggest that a planet with a mass 6 to 8 times that of Earth could have a layer of water more than 100 kilometers thick. The enormous pressure of this water could reach up to 20,000 times the pressure of Earth's atmosphere, depending on things like temperature, impurities, and other factors. This pressure would be enough to create strange forms of ice, different from the water ice we know. Some of these ice types could stay solid even at high temperatures. For example, a type of ice called Ice 7 could form under these conditions, and it would be heavier than liquid water. The density of Ice 7 is thought to be around 1,650 kilograms per cubic meter, making it heavy enough to sink to the ocean's bottom, where it would form a thick ice layer, or cryosphere, that surrounds the planet's core. The chance to test these ideas came in 2009 when scientists discovered a small, dim star located 42 light-years away called Gliese 1214. This red dwarf star is much smaller than our Sun, with a diameter only 5 times smaller and a mass of just 15.7% of the Sun's. It's also 300 times dimmer, with a surface temperature of just 3,000 Kelvin, about 2,700 degrees Celsius, making it a typical, unremarkable red dwarf like many others in our galaxy. However, in the same year, astronomers found a planet orbiting Gliese 1214 called Gliese 1214b. This exoplanet is special, with a diameter 2.5 times that of Earth and a mass 6.5 times heavier. Simple calculations suggest that the gravity on its surface is only 91% as strong as Earth's. Gliese 1214b's average density is about 170 kilograms per cubic meter. This relatively low density suggests that the planet is mostly made of metals and rocks, similar to Earth. But interestingly, the density also suggests that about 75% of the planet's mass could be water or ice, with the remaining 25% being rock. This makes Gliese 1214b appear to be an ocean planet, with vast seas of water or water-based ice. The planet orbits very close to its star, at an average distance of just 2 million kilometers, or 0.0014 astronomical units, which is 75 times smaller than the distance between Earth and the Sun. The orbit is also quite stretched, meaning that Gliese 1214b gets twice as close to its star at its closest point, perihelion, as it does at its farthest point, aphelion. The planet completes one full orbit around its star in about 36 hours. The red dwarf star Gliese 1214 is much dimmer than our Sun, about 300 times less bright. However, despite its faintness, the proximity of the planet Gliese 1214b to this star causes its climate to be incredibly hot. If the planet's surface reflects sunlight the same way Venus does, temperatures on Gliese 1214b would be around 393 Kelvin, or roughly 120 degrees Celsius. But if the surface is darker and absorbs more heat, the temperature could soar to 553 Kelvin, which is a scorching 280 degrees Celsius. One fascinating aspect of Gliese 1214b is that its orbit crosses in front of the star, allowing scientists to study its atmosphere using a technique called spectroscopy. However, the results so far have been unclear. If Gliese 1214b were an ocean planet, scientists would expect its atmosphere to be filled mostly with water vapor and some other gases. Yet, surprisingly, no traces of hydrogen, helium, or complex compounds like water, carbon dioxide, or ammonia have been detected in its spectrum. It's believed that the thick outer layer of the planet's atmosphere may be hiding its true composition. The conditions on the surface of Gliese 1214b are extreme, almost like being inside a massive steam boiler. The atmospheric pressure in the lower layers is at least 15 times greater than Earth's. The ocean and atmosphere are so tightly connected that it's hard to tell where one ends and the other begins. The water vapor near the ocean's surface is almost as dense as constantly boiling water. As you go deeper, the pressure increases, and by the time you reach 100 kilometers beneath the surface, the pressure is so intense that water can't remain liquid, even at such high temperatures. Instead, the bottom of the ocean is covered in dense, heavy ice, which is estimated to be more than 5,000 kilometers thick. Below this ice layer, there is likely a core made of rocks and metals. Sadly, the chances of life evolving on an ocean planet like Gliese 1214b are slim. Even if the surface temperatures were more favorable, the oceans of such planets usually lack the necessary microelements that are crucial for life. Even though meteorites bombard these planets from time to time, they don't bring enough chemical variety to spark life. Still, the study of ocean planets remains a fascinating pursuit for scientists. According to a 2020 estimate by NASA's mathematical models, there could be billions of planets like Gliese 1214b in our galaxy. Some might be cold, with oceans hidden beneath ice, while others could be warm, like this one. Since water is one of the most common complex chemicals in the universe, the search for ocean planets continues, offering hope for discoveries in the future. Far out in space, hundreds of light years away from Earth, there is a huge cloud, a vast unknown area where stars are born. This giant nebula contains many places where new stars are forming, hidden from our view. Some parts of this cosmic cloud are violently ripped apart by huge bursts of energy, while other sections are so filled with harmful radiation that they could destroy anything in their path. Among the swirling hot gases and fiery whirlpools of hydrogen, whole star systems can be swallowed up and lost forever. This place where stars are made is called the stellar nursery. Among the many star-making areas scattered throughout the galaxy, some are small and simple, while others stretch across huge distances, some even covering hundreds of light years. These nebulae are made of space gas and dust, slowly being crushed together by the strong pull of gravity. Most of these clouds are nearly invisible against the vast emptiness of space, but a few are bright enough to be seen from Earth with the naked eye. One such nebula is the famous Orion Nebula, which lies about 1,344 light-years from Earth. It's part of the Sword in the Orion constellation, a group of 3 stars that forms a clear, recognizable line in the night sky. The Orion Nebula stands out because it is not only huge, but also relatively close to Earth. Its size and closeness have made it an object of interest for scientists since the early days of astronomy. This giant nebula is one of the most studied objects in space, partly thanks to the Hubble Space Telescope, which took amazing pictures of it in 1993. These images showed the nebula's amazing range of colors, from deep reds to bright blues and purples. One especially strange feature was the bright green lines that appeared in some parts of the nebula. At first, scientists were confused, as the radiation causing this effect didn't match any known chemical elements at the time, leaving them to wonder what secrets this glowing cloud might still be hiding. At one point, scientists suggested an interesting idea: a mysterious element called nebulium, believed to not exist on Earth, but thought to be found in clouds in space. However, as science advanced, it was discovered that the strange light seen in these clouds came from a rare and charged form of oxygen. This discovery explained not only the unusual glow of nebulae, including our own Sun, but also helped us understand the vast and complex world of the Orion Nebula. Today, astronomers have found over 3,000 stars within this nebula, along with huge clouds of gas and many young stars, called protostars. These amazing space objects are all packed into a region about 23 light-years wide, interacting with each other in ways that are still being studied. The total mass of all the material in this region is around 10,000 times that of our Sun. If we take a closer look at the Orion Nebula, we can spot several different areas, each with its special features. One of the most noticeable parts is a group of stars called the trapezium, or Theta-1 Orionis. This open star group, which is about 300,000 years old, consists of 8 main stars, some of which are in pairs, while others stand alone. The brightest and most noticeable stars in the trapezium are 4 star systems, named using letters of the Latin alphabet. These stars are packed closely together within a region just about 1.5 light-years across. Each of these stars has a mass between 15 and 40 times that of our Sun, making them young and extremely hot. Among them, Theta-1 Orionis C stands out as the most massive and brightest star, not just in the trapezium, but in the entire nebula. This star is a white-blue giant with a mass of around 40 solar masses and a radius 8 times that of our Sun. Its surface temperature reaches around 45,000 degrees Kelvin, and it shines with a brightness about 250,000 times greater than our Sun. The strong radiation from Theta-1 Orionis C lights up almost the whole nebula around it, but there's little gas close by. This is because stars of this type often create powerful stellar winds that push material far away, scattering the gas into the surrounding space. If we travel a few light-years away from the trapezium, we'll find another interesting system, Theta-2 Orionis. This system consists of 3 stars held together by gravity, located near the Orion Bar, a huge feature of hot, glowing gas. For a long time, it was hard to study this area due to thick clouds of dust, but thanks to the James Webb Space Telescope, we've been able to capture more detailed images of this amazing region, showing the stunning complexity of the nebula. The first star in the Theta-2 Orionis system is a bit smaller and less bright than the biggest star in the trapezium, but it's still an impressive celestial object. Its surface temperature is about 35,000 degrees Kelvin. The second star in the system is much more massive, weighing 15 times the mass of our Sun, and it shines 12,000 times brighter. The third star is also massive, with a weight of 5 times that of the Sun, and its temperature is close to 14,000 Kelvin. But it wasn't just these bright stars that caught the scientists' attention. Using the James Webb Space Telescope's infrared cameras, they were able to spot hidden objects that were previously invisible, buried deep in the gas and dust clouds of the Orion Nebula. Thanks to this powerful technology, about 180 mysterious objects, known as protoplanetary disks, have been found at the center of the nebula. These are dense, dark disks of gas and dust that surround stars still in the process of forming. One of the most interesting discoveries is a star called Orion, which is only about 1 million years old. It's surrounded by a huge disk of gas and dust that stretches about 300 times the distance from Earth to the Sun. Because Orion is fairly close to Earth, scientists can study its structure and size in great detail. In just a few million years, it is expected to enter a stable phase known as the main sequence, and it will likely have a system of exoplanets and possibly moons orbiting it. The night sky of these future planets will be an amazing sight. Imagine a sky filled with a bright, multicolored glow from countless stars, much more numerous than what we see from Earth. From time to time, huge swirls of glowing gas would cover half the sky, turning the night into a glowing twilight. If we move further out to look at the larger region, we can see that most of the nebula is filled with scattered gas. The center of the cloud is made up of highly charged hydrogen, which absorbs high-energy radiation from nearby stars. The temperature of this gas can rise to around 10,000 degrees Kelvin in the heart of the nebula, but it cools quickly as we move toward the edges. The differences in temperature and pressure, along with the strong winds from stars, create huge currents and swirling whirlpools in space. These currents can reach speeds of up to 50 kilometers per second, and some of them are so big that they are larger than our entire solar system. In some parts of the nebula, long, thin strands of cooler molecular hydrogen stretch across several light years. These strands are made up of hydrogen without methane, ethane, or water, adding yet another mysterious layer to this stunning cosmic scene. As we move farther out, we come across the center of the Orion Nebula, which is covered by a huge cloud of cooler, denser gas. This cloud interacts with the bright stars and the glowing hydrogen, creating a beautiful display of light in many colors. Hidden behind this curtain are hundreds of objects in space that cannot be seen with the naked eye. However, with the help of infrared cameras and modern telescopes, we can look through this cosmic fog. By combining data from different sources, astronomers have found about 700 protostars at different stages of development in this area. These stars are spread out more sparsely than in the nebula's center because of the weaker pull of gravity from the surrounding gas. Most of these objects are still very young in cosmic terms and are still forming. According to current ideas about star development, new stars are created through the slow collapse of large clouds of space gas. As this happens, large nebulae break up into smaller, tightly packed areas that soon become protostars. These groups of young stars are called stellar nurseries, or, more scientifically, regions of star formation. At some point, the internal pressure of the gas becomes so strong that it balances the pull of gravity, bringing the protostar into a temporary state of balance. Meanwhile, the remaining gas forms a large spinning disk. Some of this material is pulled into the forming star, while the rest is pushed far beyond the star's reach. The young star's growing magnetic field also plays a role in this process. As charged particles are pulled along the magnetic lines, they speed up and are eventually thrown out at incredible speeds. These flows can reach up to several hundred kilometers per second, and when they crash into nearby gas clouds, they create swirling whirlpools and half-spheres called Herbig-Haro objects. These objects are not only interesting because of their size and movement, but they also produce light and heat as energy is released during the collisions. The high-speed movement of the gas also causes shock waves to spread through the surrounding material, which can be detected by telescopes. Since stellar nurseries contain many closely spaced protostars, each releasing gas in different ways, it's no surprise that Herbig-Haro objects come in many shapes and colors. They are often the result of large cosmic interactions, making them very unstable and unpredictable. These objects change color and shape quickly, usually disappearing entirely over tens of thousands of years. During this time, they can travel anywhere from 1 to 3 light years from their parent stars. So far, about 400 such objects have been found, but the total number in the Milky Way is thought to be around 150,000. One clear example of this phenomenon can be seen in the Orion Nebula, where huge bullets of gas, each hundreds of astronomical units across, are moving at amazing speeds. These bullets can cut through thinner hydrogen clouds, creating shock waves that stretch out across the nebula. Spectral analysis shows that the tips of these bullets contain glowing iron atoms in the infrared spectrum. These bullets are thought to be about 1,000 years old, and their origin is still a mystery, possibly linked to some kind of disaster. Beyond the Orion Nebula, we discover that it is part of a much larger cosmic structure called the Orion Molecular Cloud. This huge region stretches for hundreds of light years and covers much of the Orion constellation we see in the night sky. One of its many interesting features is the Hubble's Head Nebula, a dense cloud of dust about 3.5 light-years across. The nebula stands out against a background of red light. Not far from the Orion Nebula is the Barnard Loop, a giant nebula formed by a series of supernova explosions that happened about 3 million years ago. The shock waves from these explosions mixed with the surrounding gas, forming a huge, curved nebula that glows red from the energy of nearby young stars. Despite its beauty, the Orion Nebula is a delicate and unstable structure by cosmic standards. Stellar winds, the pressure from the light given off by the young stars, and the turbulent gas emissions constantly push and spread out the material that makes up the nebula. It has already lost about 60% of its original mass, and in about 100,000 years, the nebula will no longer exist in its current form. Instead, a group of stars, similar to the Pleiades, will remain. For a while, these stars will move together as a group, but eventually each star will travel in its direction, continuing its journey through the vast expanse of the galaxy. The first stop on our journey takes us 202 light-years away from Earth to a star known as K211, an orange dwarf. This star has about 7 times the mass of our Sun, but its radius is only 68% that of the Sun. Despite the differences, the star's temperature is around 4,600 Kelvin, which is about 20% cooler than our Sun. Now let's focus on the planet K2-141b, located just 0.007 astronomical units from its star. This planet is truly strange. It's a rocky exoplanet, about 5 times heavier than Earth, with a radius of 1.5 times that of our planet. Because of its size and mass, we can expect the gravity on K2-141b to be at least twice as strong as Earth's. Its dense, metallic core makes up a significant portion of the planet's mass, around 20 to 50%. The planet takes just 6.5 hours to complete an orbit around its star. This close distance causes the planet to be tidally locked, meaning one side always faces the star, while the other side remains in perpetual darkness. On the day side, temperatures soar to a scorching 3,270 K, around 3,000 degrees Celsius, hot enough to melt most rocks and metals and even cause them to vaporize. Scientists believe the day side is covered by a vast ocean of molten lava that's always bubbling and churning. The atmosphere of K2-141d is unlike anything we know, composed of steams made up of heavy metals and silicates. On the opposite side, the night side of the planet is cold, with temperatures plunging tens of times lower than those on the day side. The temperature on the night side is believed to be well below freezing. This extreme temperature difference between the day and night sides creates incredibly strong winds, reaching speeds of up to 1.75 km/s, about 5 times the speed of sound. These powerful gusts whip across the planet's surface, creating deafening, rumbling sounds that never stop. The planet is a constantly shaking, turbulent world where the weather alone would be enough to overwhelm any earthly senses. It's believed that on the night side of this planet, the gases in the air start to cool and form droplets, which fall to the surface as burning rain. This rain creates rivers of lava, and over time, these hot rivers cool, causing metals to sink back into a molten sea beneath the surface. From there, they eventually turn into gas again, continuing this amazing cycle of heat and energy. However, this strong process only happens on a small part of the night side. The problem is that the gases from the planet's hot day side don't reach the main part of the night side. Instead, they fall near the border, meaning the central night side is probably a frozen desert covered in thick layers of solid rock. Interestingly, K2-141b is not even the hottest planet we know. For comparison, there's another planet, Kelt 9b, located about 670 light-years away, whose surface temperature reaches an amazing 4,600 Kelvin, about 4,530 degrees Celsius. In contrast, the outer layers of most red dwarf stars are much cooler than this planet's surface. This shows just how incredibly hot Kelt 9b is. It's similar in temperature to some stars. Kelt 9b orbits a star called Kelt 9, which is much bigger and hotter than our Sun. Kelt 9 has a whitish-blue color and is 2.6 times as heavy and 2.3 times as wide as the Sun. Its surface temperature is around 10,170 Kelvin, or a very hot 99,900 degrees Celsius. These extreme conditions are partly because Kelt 9b orbits its parent star very closely, only 0.35 times the distance between Earth and the Sun. The planet completes one full orbit in just 1.5 days. Kelt 9b is a gas giant, much like Jupiter, but it's much heavier, almost 3 times as heavy, and its size is about twice as large. Based on what we know about gas giants, it's believed that the inner atmosphere of Kelt 9b could be even hotter, with temperatures reaching as high as 11,000 Kelvin. This intense heat is caused by the ionization of heavy metals in the planet's atmosphere. The conditions on Kelt 9b are truly extreme, far beyond anything we experience on Earth. The atmosphere of this distant planet contains unusual elements like vaporized iron and titanium, in addition to the more familiar components such as hydrogen and helium. Its close orbit around a parent star and the intense heat has caused the planet to gradually lose its atmosphere. Over time, powerful stellar winds blow the atmosphere away into space, which is why the planet is surrounded by a cloud of thin, rarefied gas. This gas will eventually be pulled back in and absorbed by the star. Interestingly, some studies suggest that the planet loses up to 68 times the mass of Earth every billion years. If this continues, the planet might eventually lose all its atmosphere and turn into a barren, rocky world. However, this process might take a very long time, and the parent star is likely to reach the final stages of its life. Before then, eventually swallowing everything within its reach, including the planet. This is a stark reminder that stars don't just warm planets, they can also destroy them. Other celestial bodies in the universe have already felt the full wrath of their parent stars. One such object is located 4,570 light-years from Earth, orbiting a small star called V391 Pegasi. This star is a white dwarf, about half the mass of our Sun and only about 23% of its size. Its surface temperature is incredibly hot, nearly 30,000 Kelvin. By now, all the thermonuclear reactions inside the star have stopped, and it's slowly cooling down. Eventually, it will transform into a black dwarf over the next hundreds of billions of years. The planet orbiting V391 Pegasi, known as V391 Pegasi b, has an extraordinary history. Mathematical models suggest that this planet not only survived the star shedding its outer, but came dangerously close to being engulfed by the star itself. When the star expanded into a red giant, its outer layers, extremely thin by then, nearly touched the planet's orbit. Despite the vast difference in density between the star's layers and the planet's atmosphere, the planet didn't get destroyed instantly. It slowly lost speed and began spiraling inward toward the hotter, denser layers of the star. However, before it could be completely consumed, the star shed its outer layers and the planet managed to survive. Today, V391 Pegasi b is a gas giant about 3 times the size of Jupiter. It orbits the star at a distance of 1.7 astronomical units and takes around 1,170 Earth days to complete one orbit. It's unclear how the planet was able to retain such a large mass after being so close to the star's scorching layers. The star's transformation caused significant changes to the planet's orbit and physical characteristics, but the planet's past before it came into contact with the star's plasma remains a mystery. The universe is filled with objects that possess strange and even mind-boggling characteristics, many of which are invisible to regular telescopes, but detectable through radio waves. Pulsars, for example, are neutron stars that spin incredibly fast, emitting regular bursts of electromagnetic radiation. One such pulsar, located about 4,000 light-years from Earth, has a particularly intriguing set of features. Its diameter is just 20 kilometers, and its mass is 1.4 times that of the Sun. It spins at an astonishing rate, around 10,000 rotations per minute, while emitting powerful radiation beams. Nearby, there's a planet in orbit around this pulsar. The surface of this planet is constantly bombarded by these lethal radiation pulses, making it an extremely hostile place. The planet completes a full orbit around the pulsar in just 2 hours, and it orbits at a distance even smaller than the Sun's radius, only 600,000 kilometers away. The planet's mass is about 330 times that of Earth, and its radius is 4 times larger than Earth's. This results in gravity 20 times stronger than on Earth. The planet's density is extraordinary, about 23 grams per cubic centimeter, denser than most known substances. It's believed that the planet is largely made of crystallized carbon, with some oxygen bound to the carbon. It seems unlikely that this planet could have survived a supernova event. More realistically, the planet probably formed after the star went through its life cycle and turned into a pulsar. It may have been a leftover piece of debris from a white dwarf, a remnant of a dying star whose material scattered across space. Regardless of its origin, this world remains one of the most dangerous and uninhabitable places in the universe. About 650 light-years from Earth, there is a huge red giant star called IRC Plumosnoso 2116, or CW Leonis. This giant star is incredibly large. At its biggest size, its radius grows to about 560 times that of the Sun, which is around 2.6 times the distance between Earth and the Sun. If CW Leonis were at the center of our solar system, it would easily cover planets up to Mars, with its outer edges reaching the inner part of the asteroid belt. Surprisingly, despite its enormous size, CW Leonis isn't very heavy. Its mass is estimated to be between 1.5 and 4 times that of the Sun. Its surface is not as hot as most stars, with a temperature of around 2,300 Kelvin, about 2,000 degrees Celsius. However, its great size allows it to give off about 8,500 times more energy than the Sun. Like other red giants, CW Leonis is nearing the end of its life. Scientists think the star is several billion years old. Long ago, it was probably a bright blue-white star with a mass 3 to 5 times greater than the Sun. Over time, most of its hydrogen fuel burned out, turning into helium that gathered in the star's center. This helium pushed the remaining hydrogen outward, creating a very hot core. But this core no longer had the reactions that produced energy, starting the star's change into a red giant. The pressure inside CW Leonis made it expand greatly, causing its outer layers to become thinner and unstable. Its once bright color faded to the deep red typical of red giants. Inside, nuclear reactions still occur, producing intense pressure and heat. At one point, a major event called the helium flash happened. During this, helium atoms combined to form carbon, leading to a big rearrangement of the star's internal structure. The core became extremely hot, while the outer layers cooled and dimmed. Today, CW Leonis contains a lot of carbon, but it isn't heavy enough to support further nuclear reactions. Instead, its interior goes through cycles of cooling, shrinking, heating, and expanding. These cycles cause the star's brightness to change over 649 days. At its brightest, CW Leonis is 11,300 times brighter than the Sun, and at its dimmest, it still shines 6,250 times more brightly. When the star shrinks, some of its outer layers break away, forming a beautiful cloud of gas rich in carbon and oxygen around it. This cloud, or nebula, has been forming for at least 69,000 years and has about 1.55 times the Sun's mass. It is massive, stretching out to 84,000 astronomical units. Within this huge cloud, scientists have noticed shapes like arcs, bulges, and uneven rings, likely caused by the star's magnetic activity and winds. The chemical makeup of the nebula is especially interesting. Scientists using light analysis have found around 70 different substances, including carbon dioxide, water, and ammonia, as well as heavier elements like iron. This variety makes CW Leonis an exciting object for study as it reveals details about the processes in dying stars. Some scientists think CW Leonis may have once had planets, but they were probably swallowed during the star's growth into a red giant. No direct evidence of these planets exists, though small movements in the star, seen in 1994 and 2017, hint at possible past interactions. Astronomers have detected strange movements in the gas and dust cloud surrounding CW Leonis, a dying red giant star. These shifts might be caused by a small, faint red dwarf orbiting the star, though efforts to detect its light have failed so far. This failure could be due to the nearby nebula, which scatters and reflects light, making it nearly impossible to identify objects in the area. If this companion star exists, it's likely much smaller than the Sun and would take about 100 years to complete one orbit around CW Leonis. Another curious feature is the surprisingly high amount of water vapor found in the star's surroundings. Initially, scientists thought the star absorbed icy comets as it expanded, melting them into water. However, in 2009, observations revealed water vapor forming in the star's upper layers at incredibly high temperatures, around 1,000 Kelvin. This discovery didn't match the existing models of red giants, which predicted that oxygen in such stars would bond with carbon to form carbon monoxide, leaving no oxygen for water formation. To explain this anomaly, researchers proposed a bold new idea. They suggested that intense ultraviolet radiation might break apart molecules like silicon oxides and carbon, freeing oxygen to combine with hydrogen and form water vapor. However, this theory raises another question. Where does the ultraviolet radiation come from? Red giants, like CW Leonis, have dense outer layers that usually block such radiation. Scientists speculate that occasional ruptures in the star's surface might allow ultraviolet rays to escape, triggering these reactions. The mass of water vapor in CW Leonis's atmosphere is staggering, several quintillion tons, though it's still a tiny fraction of the star's total mass. As a red giant, CW Leonis is nearing the end of its life. In 10,000 to 30,000 years, it will run out of fuel, eject its outer layers in a dramatic explosion, and shrink into a dense white dwarf. This leftover core will retain about 80% of the Sun's mass, but will cool and dim over billions of years, eventually fading into a cold, dark, black dwarf. Before this quiet end, the explosion will create a brief moment of cosmic fireworks. The intense heat and shock waves will forge heavy elements like gold, lead, and uranium. These elements will later scatter through space, becoming part of new stars, planets, and possibly even life. While the universe is shaped by cycles of destruction and creation, every end paves the way for a new beginning, continuing the story of cosmic evolution.